The National Electrical Code (NEC) permits the use of a smaller equipment grounding conductor within multi-conductor cable assemblies. Specifically, Section 250.122 B of the NEC outlines the requirements for equipment grounding conductors in relation to overcurrent protection devices. When dealing with cables possessing ampacities of 100 amps or less, the equipment grounding conductor size is dictated by Table 250.122. This table is crucial for determining the appropriate grounding conductor size based on the rating of the overcurrent protective device in the circuit, such as a circuit breaker or fuse. Table 250.122 explicitly allows for the utilization of a No. 10 American wire gauge (AUG) equipment grounding conductor when paired with No. 8 AWG ungrounded conductors. This allowance is predicated on the cable assembly adhering to specific standards and being used within its designed ampacity range. The Underwriters Laboratories (AL) Standard 1569, which governs metal-clad cables, also acknowledges the possibility of employing reduced equipment grounding conductors in MC cable. UL 1569 serves as a safety standard, ensuring that metal-clad cables meet stringent performance and safety criteria. Within the framework of UL 1569, a No. 10 AWG equipment grounding conductor is permissible in MC cable configurations utilizing No. 8 AWG ungrounded conductors, provided that the cable is installed correctly and operated within its intended parameters. Proper installation and usage are paramount to ensuring the integrity and safety of the electrical system. Considering a scenario involving 8/2 CMC cable supplying a 120-volt circuit protected by a 20 amps breaker, it is evident that the circuit falls well within the ampacity threshold of 100 amps or less. Consequently, the use of a No. 10 AWG equipment grounding conductor is deemed acceptable in accordance with both NEC Table 250.122 and UL 1569. This determination underscores the importance of adhering to established standards and guidelines when designing and implementing electrical systems. It is crucial to recognize that the provision outlined in NEC 250.122 B, which mandates an increase in equipment grounding conductor size proportional to the ungrounded conductors, exclusively pertains to raceways and does not extend to multi-conductor cable assemblies. Raceways, such as conduits or tubing, necessitate a different approach to grounding compared to pre-assembled cables. The application of a No. 10 AWG equipment grounding conductor in this scenario aligns with the stipulations outlined in both the NEC and UL 1569, thereby rendering the installation compliant with prevailing standards. Any challenge to the installation based on a misinterpretation of NEC 250.122 B would be deemed invalid. It is important to note that the NEC, or National Electrical Code, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advancements in technology and best practices. The NEC is not law itself, but it is widely adopted by states and municipalities as part of their building codes. Compliance with the NEC is essential to ensure the safety of people and property. The UL, or Underwriters Laboratories, is a global safety certification company that tests and certifies products to ensure they meet established safety standards. UL certification is widely recognized and respected, and it demonstrates that a product has been rigorously tested and meets the requirements for safety and performance. UL 1569 is a specific standard for metal-clad cables, and it covers the construction, performance, and safety requirements for these types of cables. Metal-clad cables are commonly used in commercial and industrial applications, and they provide a high level of protection against physical damage and environmental factors. When selecting and installing electrical equipment, it is important to choose products that are UL listed or certified. This indicates that the product has been tested and meets the applicable safety standards. It is also important to follow the manufacturer's instructions for installation and use to ensure that the equipment operates safely and effectively. There are several key considerations when sizing equipment grounding conductors. Firstly, understanding the role of the equipment grounding conductor is paramount. It provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protective device and clear the fault quickly. This is crucial for preventing electrical shock and fire hazards. Secondly, it is important to consult NEC Table 250.122, which provides the minimum size requirements for equipment grounding conductors based on the rating of the overcurrent protective device. This table takes into account the ampacity of the circuit and the potential fault current that could flow in the event of a ground fault. Thirdly, it is crucial to consider the type of wiring method being used. As mentioned earlier, the requirements for equipment grounding conductors and maceways differ from those in multi-conductor cables. It is essential to select the appropriate grounding conductor size based on the specific wiring method being employed. When dealing with long circuit runs, it may be necessary to increase the size of the equipment grounding conductor to compensate for voltage drop. Voltage drop can occur when current flows through a conductor, and it can reduce the effectiveness of the grounding system. By increasing the size of the grounding conductor, the impedance of the grounding path is reduced, which helps to minimize voltage drop and ensure that the overcurrent protective device trips quickly in the event of a ground fault. It is important to note that the equipment grounding conductor must be properly connected to the grounding electrode system. The grounding electrode system provides a connection to earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to flow to ground. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, crown plates, or metal underground water pipes. The equipment grounding conductor must be connected to the grounding electrode system at the service entrance or at the source of a separately derived system. In addition to the equipment grounding conductor, there is also a bonding conductor, which is used to connect metal parts of equipment together to create a low impedance path for fault current. Bonding conductors are typically used to bond metal enclosures, raceways, and other metal parts of equipment. The bonding conductor must be sized in accordance with NEC Table 250.102, which provides the minimum size requirements for bonding conductors based on the size of the circuit conductors. It is important to ensure that all bonding connections are tight and secure to provide a reliable path for fault current. When working with electrical systems, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing circuits before working on them. It is also important to use properly insulated tools and equipment and to avoid working in wet or damp conditions. If you are not qualified to work on electrical systems, it is important to hire a licensed electrician. Licensed electricians have the training and experience necessary to perform electrical work safely and in accordance with the NEC. They can also help you to ensure that your electrical system is properly grounded and bonded to protect against electrical shock and fire hazards. To recap, the use of a NER 10 AWG equipment grounding conductor with NER 8 AWG ungrounded conductors and NC cable is generally permitted by the NEC and UL standards, provided that the cable is used within its ampacity rating and is properly installed. The specific requirements for equipment grounding conductors can vary depending on the wiring method and the size of the overcurrent protective device. It is always important to consult the NEC and other applicable standards to ensure that the electrical system is installed safely and in compliance with all requirements. In conclusion, understanding the nuances of equipment grounding conductor sizing in multi-conductor cable assemblies requires a careful examination of the relevant NEC provisions and UL standards. By adhering to these guidelines, electrical professionals can ensure the safety and reliability of electrical systems while upholding the integrity of established codes and regulations. Remember to always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. Furthermore, it is advisable to seek guidance from qualified electrical inspectors or engineers when faced with complex or ambiguous situations. Proper grounding is a critical aspect of electrical safety, and it is essential to prioritize compliance with all applicable standards to protect people and property from electrical hazards. This discussion highlights the importance of staying informed about changes and updates to electrical codes and standards. The electrical industry is constantly evolving, and new technologies and best practices are emerging all the time. By staying up to date on the latest developments, electrical professionals can ensure that they are providing the safest and most efficient electrical services possible. Moreover, it is essential to foster a culture of continuous learning and improvement within the electrical industry. Encouraging electricians to participate in continuing education courses, attend industry conferences, and seek out mentorship opportunities can help to raise the overall level of knowledge and expertise in the field. This, in turn, will lead to safer and more reliable electrical systems for everyone. In addition to the technical aspects of equipment grounding, it is also important to consider the ethical implications. Electrical professionals have a responsibility to protect the public from electrical hazards, and this responsibility extends to ensuring that electrical systems are properly grounded and bonded. Cutting corners or making compromises on safety can have serious consequences, and it is never worth the risk. Always prioritize safety and compliance with all applicable codes and standards. Furthermore, it is important to communicate effectively with clients and other stakeholders about the importance of proper grounding. Many people do not understand the role of grounding in electrical safety, and it is up to electrical professionals to educate them. By explaining the benefits of proper grounding and addressing any concerns they may have, you can help to build trust and ensure that they are making informed decisions about their electrical systems. In addition to the NEC and UL standards, there may also be local codes and regulations that apply to electrical installations. It is important to be aware of these local requirements and to ensure that all electrical work is performed in compliance with them. Local codes may be more stringent than the NEC in some cases, and it is important to follow the most restrictive requirements. Finally, it is important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals. If you are not qualified to work on electrical systems, it is important to hire a licensed electrician. Licensed electricians have the training and experience necessary to perform electrical work safely and in accordance with all applicable codes and standards. They can also help you to ensure that your electrical system is properly grounded and bonded to protect against electrical shock and fire hazards. Proper grounding is not just a technical requirement, it is a fundamental principle of electrical safety. By understanding the principles of grounding and following all applicable codes and standards, electrical professionals can help to protect people and property from electrical hazards.